Selling your car to Carvana is as easy as...
As easy as pie?
Sure. All you have to do is enter your license plate or VIN.
As easy as a stroll in the park.
Okay, then just answer a few questions and you'll get a real offer in seconds.
As easy as singing.
Why not? Schedule a pickup or drop-off and Carvana will pay you that amount right on the spot.
As easy as playing guitar.
Actually, I find that kind of difficult. But selling your car to Carvana is as easy as...
Can be.
Visit Carvana.com or download the app to get an instant offer today.
From Audioboom comes Covert, a new podcast that delves into the murky world of spies, soldiers, and top-secret military operations. I'm Jamie Rennell, and together we'll discover the real stories of history's greatest classified missions, told by the operatives, soldiers, and journalists who experienced it firsthand. Follow Covert on Spotify, or subscribe now on Apple Podcasts, Stitcher, or wherever you find your favorite shows.
Today's episode of Space Nuts is brought to you by Moonshot, a new podcast from Lawson Media. Find out more at www.moonshot.audio.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the astronomy podcast known as Space Nuts. I'm your host, Andrew Dunkl, and with me, as always, my partner in crime and the cosmos, Fred Watson from the Australian Astronomical Observatory. Hi, Fred.
From one astro-criminal to another. Hello, Andrew.
Good to be with you again, Fred. And in this episode, we are going to look at a potential major discovery on Saturn's moon, Titan. This has got a lot of people excited, which, if held true, could be one of those discoveries we have been fairly excited about and talked about many, many times. We also have the unusual situation where financial accounting meets a universal recession and more water on the moon than we first thunk. So we'll look at those later. But this potential discovery, and I'm saying potential because I'm not sure they're quite to the confirmation stage yet, but Saturn's moon Titan may have revealed a pretty incredible secret.
Indeed, it may have. Well, indeed, it already has, actually, Andrew. The molecule in question has been detected in Titan's upper atmosphere. So what molecule are we talking about? Well, we're talking about something called vinyl cyanide. And, of course, you and I, as soon as any word comes out that's got cyanide attached to it, we reel with horror.
Alarm bells.
Because alarm bells start ringing. And in fact, we talked about cyanide recently. We talked about methyl isocyanate, which is another horrible compound that's also been found out in space. But the vinyl cyanide detection actually has come, indeed, from the same telescope that measured the methyl isocyanate a little while ago. It's ALMA, the Atacama Large Military... The Atacama... It's too early in the morning. ALMA, the Atacama Large Millimeter Array, an array of telescopes at about 5,000 meters high up in the high Atacama, not very far from San Pedro de Atacama. This is a radio telescope, essentially, that particularly looks at molecules, these atoms joined together to form the chemical compounds that we're all familiar with. And the news from ALMA is that they have detected vinyl cyanide in the upper atmosphere of Saturn's moon Titan. Now, Titan, of course, one of the most interesting places in the solar system, certainly the only other place known in the solar system, in fact, the only other place known in the universe so far, apart from the Earth, that has bodies of liquid on its surface. It's got seas of methane and ethane on its surface, an atmosphere that is largely nitrogen, but has a fair bit of methane and ethane in it, making this kind of hydrocarbon smog that blankets Titan in this fairly horrible brown, foggy atmosphere. However, many people think Titan is a model for the early Earth, that it's a bit like the Earth was in its early history, in its prebiotic history, if I can put it that way, before life existed. With one big difference, On Earth, of course, being nearer to the sun and in the sun's habitable zone where the temperature's just right for liquid water to exist, the life on Earth formed with water as the working fluid. But on Titan, the working fluid for any life might well be this liquid natural gas, methane and ethane. And what is exciting scientists about the discovery of vinyl cyanide is it's a molecule that we use actually on Earth in the manufacture of things like synthetic rubbers, plastics, or all these polymers that that we use in everyday life. And that gives you a hint as to what its role in nature might be, because it could be a mechanism for forming cell membranes. In other words, a membrane that will actually hold in the genetic components of, say, a microbe based on hydrocarbons rather than based on water. It's thought that it will be easier for life to kick off if you've got some method of holding the working fluid in a fairly confined volume, rather than just having these molecules wandering around in the open sea, for example, here on Earth, or the open Titanian Sea up on Titan there, because there are seas on Titan. The liquid is not water. It is, as I said, liquid natural gas. So maybe, just maybe, this might provide a way that microbial life of a very different kind from what we find on Earth could kick off on Titan. And that's why everybody's excited.
But they're not suggesting that there is life on Titan. They're just suggesting there are signs that life could develop at some stage, or are they saying there might have been in the past?
It may even be there already.
Okay.
So the detection is of these molecules high in the atmosphere of Titan, but actually that's where ALMA looks. But there seems to be a deal of confidence that such molecules will find their way down to the surface, because there's rain that falls on Titan. It's not water rain, it's methane rain, and there's a kind of haze of particles that drifts down from the upper atmosphere of Titan. Maybe these molecules have been carried down with that, and maybe there are enough of them, around near the surface for cell walls to have formed and for, early biology to be taking place. There is another little snippet to this story. It goes back to the very early days of the Cassini space probe. Of course, Cassini's still in orbit around Titan until the 15th of September. These measurements weren't made with Cassini; they were made with ALMA, as I said. But Cassini made some measurements of a depletion of hydrogen and acetylene near the surface of some of these lakes and seas on Titan. This is back 12 years ago, 11 years ago. That was something that excited astrobiologists, because there had been a prediction made that if you had microorganisms which used ethane and methane as their working fluid, they might consume acetylene and breathe hydrogen. Both these things are actually depleted near the surface of the lakes. I don't know whether that observation has ever been confirmed, but it's one of these things that just hints gently towards perhaps Titan having living organisms. Maybe not now, but in the future.
Wow, that would be incredible, and something you and I have sort of hinted at time and time again, that it's only a matter of time before we finally make this discovery. What interests me, Fred, just as a sideline question, is how is it that a radio telescope can detect these things? It sounds like we're talking about a physical object, and a radio telescope sounds like something that doesn't actually pick up physical objects. So how does that work?
Well, so what radio telescopes do is they look for molecules in a state of excitement. So a visible light telescope, if we're looking at a cloud of gas, excited gas in space, we look at the way the atoms of that cloud of gas behave, and we can tell what the gas is made of by the response of the atoms. Same thing happens with molecules, but in radio telescopes. So, ALMA is particularly good at probing these gaseous envelopes, whether disks of gas around protostars, stars that are just forming, or around places like Titan, and particularly good at sorting out what molecules are there.
So if there is life on Titan in some form or another, how long before we could either confirm or deny the existence of life.
Yeah, I know that's a trick. It's look, there are missions being planned to Titan, but they're only in the very, very early stages, and these things have a 20-year lead time, and then it's kind of it was 7 years for Cassini to get to Saturn from the Earth. That's the kind of typical journey time.
Yeah.
It's not a quick process. So I hope Space Nuts might still be going by the time such a mission is launched, but we might be getting pretty hoary in the shells of the nuts by then.
You never know. Well,
You never know.
Yeah. Well, when you're talking astronomy, you're sometimes talking billions upon billions of years. So, we've got a lot of work to do.
Absolutely.
All right. We certainly will watch this one with interest. You're listening to Space Nuts with Andrew Dunkl and, of course, Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, I don't know if you're aware of this, but in my youth, I studied accounting. But I was very bad at it, and that's why I got into radio and journalism instead. But now I see that financial accounting meets a universal recession. I mean, that's not really what we're talking about, but it's not far off the mark from what I can read here. What are we talking about?
Yeah, so we're talking about some science that's actually been done here in Australia. At the University of Melbourne. It's led from the University of Melbourne. It is an international collaboration. But this is all about the sort of checks and balances in the way early galaxies operated. And it's the analogy is being made that it's similar to the way checks and balances operate in the financial world. But it refers to the formation of galaxies in the early universe. And actually, Melbourne astronomers are particularly good at a number of universities at modelling the way early galaxies actually operated and how they built their populations of stars from the raw hydrogen gas that was really the raw material of the universe at that time. So, but this story is about the delicate balance that you need to achieve between the hydrogen supply and the formation of stars. And it's something that astronomers have thought about a lot, but there's clearly new work being done on this, and it's now being, as I said, painted in a slightly accounting way. So what happens in the early universe? The universe to start with consisted mostly of hydrogen, a lot of helium, and also this stuff called dark matter, which is one of the big mysteries because we don't really know what it is. But all that together, it was, not just a uniform cloud of stuff. It had fairly dense concentrations that formed in it over the first few 100 million years of the existence of the universe. And these dense concentrations tended to collapse under their own gravity. That's what happens in space. If you've got a gas there, you'll find little concentrations start building up. And actually filaments between them as well because of their own self-gravity. So that's happening. This hydrogen rapidly turns into stars in the middle of these dense concentrations because as hydrogen collapses, it compresses, that pushes the temperature up. Eventually, the temperature hits the 15 million or so degrees that is needed for fusion to start taking place, and you've got a star. And of course, with huge quantities of gas, you build up star cities. You build up the nuclei of galaxies, and that's how we think galaxies form. But there is clearly a balance required in terms of the fresh gas that's infalling under gravity, what we call the infalling gas, and the way that's being converted into stars. So you've got two processes here: the gravitational collapse of the cloud of hydrogen with the gas infalling, and the stars themselves compressing that gas and using it to form, basically to make stars. And so this work suggests that in the early universe and the first galaxies, there was more gas than could be coped with. So you've got this gas piling into the center of what would become a galaxy and it being turned into stars, but the stars aren't keeping pace with the gas that's falling in. And so it's an oversupply, basically. And that is the suggestion of why there was a galactic recession, because an oversupply of gas, whilst there's furious growth, as they describe it, going on in the centres of these galaxies, nevertheless, it means that, that there is a deficit of stars forming. And so the astronomers have basically charted how all that relates to what we know of the history of the universe. And they say that indeed, in the early few hundred million years, the galaxies do indeed grow very rapidly, but that is much faster than the star formation processes we see today. And so what they suggest is that eventually there will be a time when it went the other way. The stars are prolifically forming and leaving a deficit of incoming gas, and that would tend to trigger the slowdown of star formation and galaxy formation. And so what they paint is a picture of a very delicate balance between the supply of gas and the formation of stars. And that is a balance that in the rather more settled universe that we live in today, that has been achieved in a more satisfactory way. That you have a relatively constant rate of star formation, indeed taking place in our own galaxy, for example.
Well, it's all good and well until the intergalactic taxman turns up.
Well, that's right. Look, I think you've got to refer to it as an intergalactic tax person, because we really don't know, or a tax alien, a tax creature. There you are. We don't know what form that might take. No. But I think there are clearly natural, thermostatic measures that come into play with such events. An interesting paper, one that I'll keep an eye on, because I don't think I've fully understood it yet. I think there are details in this paper that I have yet to get to grips with.
Fair enough, but just I guess to cut the story to its nub, where are we in galactic financial circles right at the moment?
I think we're in a fairly reliable economy. It's not a bull market. It's not a bear market. It's, it's sort of churning along in a fairly happy state, which is what you'd sort of hope, really, because you want stability in a universe that is going to nurture living creatures.
Indeed. All right. Very interesting, and one that we probably won't see much change in for a very long time, I would expect.
We'll talk about it again in a billion years. How's that?
Sounds like a plan. All right. This is Space Nuts with Fred Watson and Andrew Dunkl.
What a matchup!
And what a team, Mike. Metro PCS and the iPhone SE for $0 on a network that covers 99% of people in the U.S. Oh, impressive.
Play with the best. Switch to Metro PCS and get a 32-gig iPhone SE for $0. Metro PCS. Coverage not available in some areas, plus sales tax and $10 activation fee. Claim based on talk and text. Not valid for active numbers currently on a T-Mobile network or active on Metro PCS in the past 90 days. See store for details and terms and conditions.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
This episode of Space Nuts is brought to you by Moonshot. Now, Moonshot is a new podcast from Lawson Media, and it explores seemingly impossible technology ideas and the people trying to make them happen. Now, these are ideas that are real, that might just change the world as we know it. The show covers topics like self-driving cars, Mars, space travel, artificial intelligence, and even the people trying to integrate technology with your body and your mind, which is just a mind explosion in itself. You can find the show on Apple Podcasts or wherever you get your podcasts, and you can get more information on the show at their website, www.moonshot.audio.
Space Nuts.
Last but not least, Fred, we are going to another moon. We talked about Titan earlier, but we're going to talk about our own moon now, Luna. And we've known for a while that it's got water around the poles, but now they're starting to think it's got more extensive supplies of water than we ever thought, which would come as some surprise, because most people would anecdotally be thinking that the moon is a dry, barren, hostile dud of a place. It is not.
You're talking about my favourite celestial object there, Andrew.
Whoops. Sorry.
No, it is. I just love the moon. It's what I guess it goes back to my youth when I first borrowed a fairly decent telescope from one of the teachers at my school and pointed it at the moon. I was just blown away.
Yeah.
It was fantastic. So all of that has conspired to make the moon a place of some scientific interest to me during my career. And this is great stuff. We've known, as you said, for a while that there is actually water ice in a fairly strong supply near the poles of the moon, and it's basically in the bases of craters that never see the light of the sun. These are craters that that are always in shadow. And so that means the temperature down there is always in the order of minus 150 Celsius or something like that. So if you have, say, a comet that collides with the moon back in early history, that comet will actually release water, H2O, good old H2O, which is frozen and basically is deposited in these craters. So we think that's where that came from. But this story is about water actually in the mantle and the crust of the moon, and that is water in a slightly different form. It's water that's basically bonded with atoms in the soil of the moon. So it's within the silica, the silicates and things of that sort.
It's mud, isn't it? That's what it is.
Yeah, if it was at room temperature, it would probably turn into mud. That's right. There you go. So this stuff has long known to be there too, because there've been experiments where spacecraft have collided with the moon, and scientists have looked at the plume of material that comes up and analysed the way it glows and what its spectrum tells you about its contents. And that reveals the presence of water. But these are some new observations that have been made basically just by looking in detail at the way the surface of the moon reflects light as the moon goes around its orbit around the Earth, because the moon's clearly illuminated from different angles as it goes through its monthly cycle and it goes through its phases. So they have looked at things like what are called pyroclastic deposits, these remains of gigantic magma eruptions from deep down within the moon's interior, and they are spread across the surface of the moon. They've looked at that and essentially found that the signature of water in those reflections is very strong. And stronger than has been expected. We knew from the lunar soil brought back from Apollo astronauts that there was water contained within actually some of the volcanic deposits in the moon. It's in these little volcanic glass beads. You find there is a signature of water in there. And what these scientists have done, and they're based in the USA, is that they have extended that to areas of the moon's surface where the Apollo astronauts didn't visit. So the suggestion is that water is everywhere in the moon's surface, and it may well be that is water that could be extracted by future astronauts visiting the moon. It could be extracted actually to make rocket fuel, because if you've got water, you can separate it into atoms of hydrogen and oxygen.
Yeah, I think it was fairly darn lazy of the Apollo astronauts not to cover more ground while they were up there. I mean, they probably use excuses like we didn't have the technology, there wasn't enough air, we would have run out of fuel. I mean, come on, guys. But it is fascinating.
They did their best.
I know, they did a great job. It's incredible.
Absolutely fabulous. As I've said many times before, one of the greatest achievements of humankind.
The other interesting thing about this is that we already knew this on Mars. We knew that there was a lot more Martian water than we first thought. We always thought Mars was a barren, dead, dry planet, and it's proven not to be. And now the moon is looking very similar in terms of its contents of water. So it's starting to look like water is a much more prevalent commodity, to use an accounting analogy again, in the universe than we might have thought.
Yeah, if there was one single piece of new knowledge about the solar system that's occurred within the last decade or so that I think is staggering, and it's exactly what you just said, that water is everywhere. Particularly, the moons of some of the outer planets, Pluto and some of those Kuiper Belt objects out there, they are mostly water. They're frozen water. So it's everywhere. It's not really surprising that we have oceans on our wonderful temperate planet.
And of course, when you and I have spoken about this in the past, we've always, I think most of science agrees, where there's water, there is potential life, and it's
certainly
everywhere.
on Earth.
It's everywhere. Yeah. So
on Earth, it is everywhere. That's
indeed.
right.
Yeah. So
watch this space.
Yes, absolutely right. All right. Thank you, Fred. As always, interesting and enjoyable. We do get a lot of questions from people now, and we're getting more and more followers on Facebook, and our download numbers are really increasing. So thank you if you've recently joined Space Nuts, because we do appreciate the support, and we certainly do encourage you to send us some questions. Which you can do via our Facebook page or via Twitter these days. We seem to be rolling along pretty well in the Twitter sphere as well. So please keep all those questions, or just comments for that matter, coming. We do love to hear from you. Fred, thank you so much. We will catch you again next time.
Sounds great, Andrew. I look forward to that, and take care.
That's Fred Watson from the Australian Astronomical Observatory. And from me, Andrew Dunkl, thank you for listening to Space Nuts. We will be back with a new edition very, very soon.
Space Nuts.
You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.
Today's episode of Space Nuts was brought to you by Moonshot, a new podcast from Lawson Media. Find out more at www.moonshot.audio.
Welcome to Mafia, a new podcast telling stories of America's criminal underworld.
Gotti assumed the position of head of the Gambino family.
And using the name Donnie Brasco, I was able to infiltrate the Bonanno crime family in New York City.
Bugsy Siegel is an American mob legend.
One man changed the whole texture and landscape of crime in America.
Listen to Mafia every Wednesday on Apple Podcasts or wherever you get your favorite shows.